Hello everyone, my name is Raghav and in this video I am going to discuss this problem. So this is an easy problem. The name of this problem is missing number in array. This problem says that you are being given an array of size n-1 and it contains n-1 distinct integers from the range 1 to n. So we have to find the missing element and there are two examples. In the first example the array contains 1, 2, 3 and 5 and the range is from 1 to 5, so it doesn't contain 4 and that's our output. In the second example 9 is missing from this array and we will just return it. Okay, so in the problem we have been given that the expected time complexity should be big of n and the expected space complexity is big of 1, and which means that we have to optimize the solution until we get this complexity. Okay, so let's start the problem. The most brute force approach for this problem can be something like this. Let's write the brute force. Here I will say that m is equal to 1. My range is the intuition is that I have a number missing between 1 and n now. So I will search from 1 to n for each and every integer in the whole array, whether 1 is present in the array or not, whether 2 is present in the array or not, until I find an element which is not present in the array. Okay, so first of all I said that let's search for 1. I will search for 1 and I found it here. Then I will say that okay, search for 2. Then here I will search for 2. So 2 is present here, which means that I have to search for 3, and search 3 is also present here, so let's search for 4. 4 is present here. Search for 5. 5 is present here, so search for 6, and 6 is present here. Search for 7. 7 is present here. Search for 8. 8 is present here. Search for 9, but 9 is not present in the array, right? So that's my answer. In this way I can find my answer. So the time complexity here is gonna be big O of n for the n elements and big O of n for the searching of these elements, which is overall big O of n square time complexity, and that's not what is expected here. And the space complexity is big O of 1 because I am just using the constant space, right? And that's our brute force approach. So we have to optimize it. The next approach we can have is sorting. What we can do is sort the array. So the array would become something like this: 1, 2, 3, 4, 5, 6, 7, 8 and 10. Then I will apply a linear search in this array, and once I find an element which is not present, now it's really easy for me to search in the array. If 1 is present in the array, I would find it at index for first index, that is index 0. For 2 I can search at ARR 1, and as soon as I find an element which is not present in the array, I will just return that this array element is not present. So here I can see that and 9 is not present, so m is equal to 9 is my answer. And the time complexity here for sorting is n log n. It took me n log n time complexity for sorting, and then after this I can just search in big O of n now. Okay, so the time complexity overall is gonna be big O of n log n. And the space complexity is big O of n because I didn't create any new array. I just have constant space memory used, extra auxiliary space memory, so it's big O of 1. Now I want to optimize it further. So what I can think of is creating a hash, like hashing. I will do it with hashing. I will create an array of size n. Here n is equal to 10, and mark all the initially I will mark all of the elements as false. When here initially I said that all of the elements are absent. Now I will traverse the array. So I will traverse the array. I found 6. So I will go to the like index for 6 and say that bro, this is present. Then I will search for 1. Let's use a different pen. Let's use a different pen to make it look better. I found 1, so I will go to index 1 and mark it true. I found 2, so I will go to 2 and mark it true. I found 8, so I will go to the 8 and mark it true. And I will just keep repeating this stuff. I will just keep repeating this stuff for this array. I go to 4 and mark it true. I go to 7 and mark it true. I found 10, so I went to 10 and marked it true. And then for 5. So after this, n minus 1 elements would have been marked. There is only one element which has not been marked true, and that's my answer. This element is missing in the array. So what I did here, the first thing is that I created an array. So the space complexity is gonna be big of n here because I'm creating a new array of size n. And talking about time complexity, I iterated over this array first, and it took me big of n. After that, I iterated over this array to search the element which is false, which is again big of n. So the time complexity is gonna be big of n. Now I have a time complexity which we were being told to have in the question. This is the expected time complexity, but the space complexity is not optimal. So we have to optimize the solution even further. The three approaches which we have discussed till now are pretty general and can be used in a lot of more problems and a lot of different problems. And the next approach which we are going to discuss might not be used in a lot of problems. So this is that we will find sum of first n integers, first n positive integers. Okay, we are discussing about positive integers here only. So I will find the sum of 1 to n and will exclude, will have it differentiated with this, the sum of this array, that is sum of ARR. Sum of ARR is nothing but it contains all the elements from 1 to n except m. There is an element m which is missing from the array, so it contains all the elements from 1 to n except m. So what will happen is it has a sum of 1, 2, 3 till 8, 9, 10, and this also has a sum of 1, 2, 3 till 8, 10. It doesn't have 9. So while differentiating this, everything would cut down except 9. So what I get as the answer is my final answer. Here the time complexity is just big of n because I only iterated over this array, and the space complexity is big of 1 because I didn't use any extra space. So finally I have reached to the expected time complexity and space complexity. So now we will discuss the last and my favorite method, which is by doing XOR. So for those who don't know about the properties of XOR, it is cumulative in nature. So I can say that A XOR B is equal to B XOR A. It is associative as well, so I can say that A XOR B XOR C in this way is equal to A XOR B XOR C. And if I XOR any number with 0, the number won't change. If I XOR any number with itself, then it will output 0. Okay, so you just need to remember these 4 properties and we will use them for finding our answer. So here I can just say that if I take XOR of this whole array and then let's say to be XOR1 the XOR of this whole array, and if I find XOR2 as the XOR of first n natural numbers, and I XOR both of these, so I will find m. So how can I definitely say that this is true? What is XOR m? So what is XOR1? It is the XOR of the first n natural numbers, the XOR of first n natural numbers except m, right? It is the XOR of first n natural numbers without m. Or what I can say is that this is the XOR of first n natural numbers and m, right? I can say it like this as well. Let me show you once again. So here I said that XOR1 is equal to 1 XOR 2 XOR 3 until XOR 7 XOR 8 and XOR 10. This is the XOR because this is the XOR of this array. It doesn't contain 9 here, so either I can say it like this or I can say it like this as well, because I know that doing it XOR with 9 XOR 9 is 0, and doing XOR of this whole expression with 0 won't change this. So basically this is also equivalent to what I wrote earlier, and which means that I can say it to be XOR of, I can say it like this now: 7 XOR 9 XOR 10 XOR 9, and this is equal to XOR 2. So XOR 1 is equal to XOR 2 m XOR m. M is the missing number here, है ना? So what if I XOR 2 both sides? What if I say that let's do XOR 2 both of the sides? These two will cut out, and here I get my expression that m is equal to XOR 1 XOR 2. So here we are going to code the problem with the XOR approach. I can say that m is equal to 0 at the starting. Here m is gonna be the missing number, and I will write some code here, and then at last I will return m. Okay, so what should be the code? As I said that we will find two integers XOR 1 and XOR 2, both of them are 0 at the beginning, and I will iterate over the array. The array is of size n minus 1, and I will just say that XOR 1 XOR is equal to XOR 1 XOR array I, right? And then I can say that for I is equal to 1 till I is less than equal to n, I will say that XOR 2 is equal to XOR 2 XOR I, and then I will say that m is equal to XOR 1 XOR 2, right? Let's see the problem again. Let's see what I did in the problem once again. I said that m is equal to 0, so basically you can just remove this as well. You don't need to use m since we are just using it in the starting and end. I can say it like this, that XOR 1 is the XOR of the whole array, and XOR 2 is the XOR of the first n natural numbers. When I XOR both of these, then the numbers which are present in the array, and all of those are definitely present in the first n natural numbers, all of those will get cut out, and only one element will remain which is not present in this array but was present in the range 1 to n, and in this way we will get our answer. So let's try to run it. And here it went good. So let's try to submit this, and it has passed all the test cases. So I hope you understood whatever I told, and please try this problem on your own as well, and please try to solve the problem with all the approaches I discussed in this video, not just with the last approach, because all of those approaches are really important and you should know about all of them. So thank you for watching the video, and bye bye.